next one, current. If it is a current, it is a voltage. Totally it is related to voltage. Now I want to go for the current. Same. Im sin theta. Theta can be written as omega t. Again, omega can be written as F can be written as 1 by t. So these are the standard. What is I? Small v and small I? Instantaneous current or voltage. Instantaneous value we call it as. This call 90 degrees, 0 degrees. This is 180 degrees. This is 270 degrees. It is this is the waveform, sine wave we call it as alternating current or alternating voltage. Y-axis, what is y-axis? Current or what is x-axis? Theta or omega t. We have to remember this waveform for all AC circuits. For all AC circuit, we have to remember the waveform. What is x-axis? Theta or omega t. What is y-axis? Current or voltage, both. You have to remember this waveform for voltage and current. That is called AC current, AC voltage, alternating current, alternating voltage. What is other name for alternating current, alternating voltage? Sinusoidal voltage, sinusoidal current, or sine wave. Or you have to remember this waveform. With help of this waveform, we'll get the formulas. With this cycle, we'll get the formulas. With this cycle, we get the formulas. Clear, all of you? What is x-axis? Theta or omega t. What is y-axis? Voltage and current. Finally, we get 0 degrees. What is instantaneous value? What is? Yes, for 10 degrees. For 10 degrees, we got some value here. This called instantaneous value. This called at 20 degrees. What is the voltage generated? At 20 degrees, this called instantaneous value. Every second will get some value. Every second will get some value. That value is called instantaneous value. Every second, the voltage generated in the copper wire. The voltage generated in the copper wire conductor. So this is the final. So I'm asking, what is the equation of the standard equation? V is equal to Vm sin theta. If it is current, I is equal to Im sin theta. That is the equation. That is the equation. With respect to waveform, we got the formulas. With respect to waveform, we got the formulas. This is waveform. Next one. Why we are discussing all the topics? Our target now, 14th topic. Problems on resistance, inductors, capacitors. To do the problems, I'm going from first onwards. Topic 1, topic 2. Now this 7th topic. Now it is a 7th topic. In 7th topic, we have to know what is average value, RMS value, form factor, peak factor, formulas. What are the formulas? Average value, RMS value, form factor, peak factor, formulas. The first formula, average value formula. Average formula is a standard formula. Remember this formula. Y means it may be voltage or current. Y means, what is Y? It may be voltage or current. Y means voltage or current. V average, I average. V average, 1 by t integral 0 to t y of t dt. Remember this formula, very important formula. You want to find out average value for any given waveform. For any given, so what is the formula you have to use? 1 by t integral 0 to t y of t dt. What is y of t? It is the equation. What is the equation? P is equal to Vm sin omega t. If it is the current, what is the equation? I is equal to Im sin theta or omega t. Y of t is the equation. Y of t is the equation for any waveform. For any, but our discussion is sine wave. Our discussion is we can draw the wave, we can find the average for any waveform. Rectangular waveform, triangular waveform, whatever waveform it may be, we can find the average value. We can find the, but our discussion is sine wave. No triangular waveform, no square waveform, no rectangular waveform, nothing else. Only discussion is sine wave. Only discussion is, so we have to find out. This is the formula you have to remember. Average value formula. Exam point of view, we will get this question. For 5 marks question. In exam point of view, 5 marks question. Define average value, define RMS value, define form factor, define peak factor, define peak value. This totally will come for 10 marks or 5 marks. Final exam question. Final exam question. Theory part. Theory part. Now formula, next one. Right. Now we have a condition that we have the waveform. You have to check the waveform before doing the average value calculation. Before doing the average value calculation, check the waveform clearly. Then only do the problem. One is symmetrical waveform. Symmetrical waveform. The other is unsymmetrical. Please check the problem whether it is symmetrical waveform or unsymmetrical. Symmetrical means both are equal. Positive is equal to negative. Both sizes are equal. Both sizes are equal. Then it is called a symmetrical waveform. If it's symmetrical waveform, the average value over one cycle is 0. One cycle is 0. So that average value is taken for half cycle. So that average value is taken for half cycle. Don't take full cycle. Don't take 0, pi, 2 pi. Don't take time period 2 pi. 1 by t, 0 to t, y of t, dt. Don't take t is equal to 2 pi. Why? Both are same. For symmetrical waveform, take only for half cycle. Do the calculation for only half cycle. Take only pi. Only pi. If it is a symmetrical waveform. If I want to calculate the average value, take only half cycle pi. 1 by pi, 0 to pi, y of t dt. What is the time period? Pi. What is the time period? Pi. Why we have taken pi? Because symmetrical positive half cycle is equal to the negative half cycle. What is the average value? 0. What is the average value? So we should not take for full cycle. We should take for half cycle. Remember that one. Check the waveform. Before doing the problem, check the waveform. Whether it is a symmetrical waveform, whether it is a unsymmetrical waveform. What is meant by symmetrical? Positive is equal to the negative. Both sizes are equal. Both sizes are equal. Then to go for only pi. 1 by pi, 0 to pi. It is a full cycle. 1 by 2 pi, 0 to 2 pi. Clear? Right. Now let's go for the unsymmetrical one. Now go for the unsymmetrical one. Unsymmetrical one, take full cycle. Unsymmetrical one, take full cycle. Take full cycle. For example, this is the unsymmetrical one. Can I say this unsymmetrical one? Negative. Can I say it is unsymmetrical one? Yes. Then it is the unsymmetrical one. Time period is 2 pi. Take full cycle should be considered. Full cycle should be considered 2 pi. Time period is 2 pi. If it is symmetrical, average value is pi. Time period is pi. Remember this one. While doing the problem, check the waveform, apply the formula. Check the waveform. If it is a symmetrical, time period is symmetrical, pi. Unsymmetrical, 2 pi. That is the thing you have to remember. For average value calculation. For average value, right. What is the standard formula? Y average is equal to 1 by t, 0 to t, y of t, dt. Time period depends upon the waveform. Time period depends upon the symmetrical, pi, unsymmetrical, for average value only. You have to remember this. Then only we'll get the problems. Then only we get the problems. Next one. RMS value formula. RMS value formula. This is the formula. Y RMS is equal to under root of 1 by t, 0 to t, y square of t, dt. You have to remember this formula, RMS value formula. RMS value formula. What is the formula? Under root integral 0 to t, y square of t, dt. So this is the formula you have to remember. Right. Now symmetrical. The RMS value can be found by considering half cycle or full cycle. If it is a symmetrical, take half cycle. Pi or 2 pi? Pi or 2 pi? Your wish. You can take for pi or 2 pi. If it is a symmetrical. If it is a, it comes under RMS value. It comes under RMS value. For unsymmetrical, the RMS value found considering full cycle should be considered. If it is unsymmetrical, take full cycle. If it is unsymmetrical, take full cycle for RMS. For RMS. So you have to remember these two sentences. Symmetrical, unsymmetrical RMS values. Formula, standard formula. Standard formula. Next, form factor. It is the ratio of RMS value by average value. Peak factor. It is the ratio of maximum value by. So these are the theory question. Define peak value, average value, RMS value, form factor, peak factor. It may come for 10 marks. Each carries 2 marks. Each carries 2 marks, 10 marks question. Theory part. It is a theory part. Please note on the formulas. We'll do the problems. We'll do the problems. Note on the formulas. Form factor is equal to RMS value by average value. P factor is equal to maximum by RMS value. Please note on the formulas. This is called a seventh topic. RMS value, YRMS. What is Y? It may be voltage or current. I or V. YRMS is equal to under root of 1 by T 0 to T y square of T dt. What is Y of T? Equation. For any waveform. For any. But our discussion is sine wave. What is standard equation? If it is a voltage, V is equal to Vm sin theta. I is equal to Im sin. That is called Y of T. That is called Y of T. Don't know this formula. This box. Answer Andaru. Right. This is called seventh topic. How many topics totally we have? 15 topics. AC circuits, 15 topics. This is the seventh topic, essay question or short question. 1 mark question, define RMS value. 1 mark bit. Final exam, 1 mark bit. Right. This 5 marks question, theory part. Eighth topic, only formulas we'll discuss. Find the average value, RMS value, form factor, peak factor for alternating current. AC current, sine wave. We can go for any waveform. Rectangular waveform, triangular waveform, square waveform. We can find out. We can find out for any waveform. This is square waveform. Find out average value. I will give the data. I will give the data. We have to find out y of t. We have to find out y of t. I will give the data. X-axis, y-axis. I will give the data. You have to find out y of t and find the average value and find the another waveform. Find out y of t. We can find out average value for any waveform, but we don't have other waveform. We have only one waveform, sine wave. We don't have syllabus. We don't have this one. We don't have this one. We have only sine wave syllabus. We don't have another waveform. We have only sine wave. And we got the equation also. Y of t is equal to, if it is a voltage, V is equal to Vm sin theta, I is equal to Im sin theta. The standard equations. But if they give another waveforms, we have to find out y of t. We have to find out y of t, then substitute in the formulas. In syllabus, we don't have this kind of waveforms. Only one waveform, alternating current, alternating voltage. Alternating current, alternating voltage. Now find out average value, RMS value, form factor, peak factor for alternating current. X-axis, what is x-axis? Theta, omega t. What is y-axis? Only current. Because my discussion is alternating current. My discussion is y-axis only current. Only current. Now find out all the values. Right. Right. First one, average current. What is the formula? 1 by t, 0 to t, y of t dt. What is 1 by t? 1 by pi. Why it is 1 by pi? Symmetrical waveform. It is a symmetrical waveform. So 1 by pi, 0 to pi. 1 by pi, 0 to pi, Im sin theta. Im, if I do this calculation part, if I go for the calculation part, the last answer is, you have to remember this formula. 2 Im by pi is equal to 0.637 Im. If I do the calculation part, we get a standard formula. What is the formula? 2 Im by pi, otherwise 0.637 Im. How you got this one? Apply the formula. What is the formula? 1 by t, 0 to t, y of t, pi. Why it is pi? Symmetrical waveform. If you do this calculation part, then this is the answer. This is the answer. This is for 5 marks question. You have to do this calculation part to get 5 marks. The question is like this, the same question. You can check the previous question papers. This is the question given. Same question given. For 5 marks question or 10 marks question. Write on the waveform. First, draw the waveform. First, draw the waveform. Then apply the formula. Then the final answer will be. This is the final. Next one, RMS current. Second one is RMS current. RMS current. Have you written the formulas? You have to write in the formulas. Have you written the formula? I average is equal to 2 Im by pi is equal to 0.637. Formulas note down. Please note down the formulas. Because we have to do the problems. Please note down this formula. Please note down this one, please. 2 Im by pi, 0.67. I average. Seventh topic. Sorry, eighth topic. Note on this formula. Next one. What is for RMS formula? Under root of 1 by t 0 to t y square of t dt. What is time period? We can take full cycle or half cycle symmetrical waveform. You can take full cycle or half cycle. What I have taken here? Full cycle. Not to worry. 1 by 2 pi 0 to 2 pi. What is y of t? I am sin theta square. I am square sin square theta. I am square. If you do this calculation part, the answer will be, this is the answer, final answer. IRM is equal to IM by root 2. IRM is equal to 0.707 IM. After doing the calculation part, apply the formula, do the calculation part. The answer will be IM by root 2 is equal to 7.70 IM. Note on this formula. Next one. RMS value, form factor. Form factor is equal to RMS value by, what is RMS value? So ఇది పైకి ఉండాలి, మిస్టేక్ జరిగింది, ఇది కిందికి రావాలి. What is RMS value? 0.707 IM. What is average value? 0.637. If you do this calculation part, IM get cancelled. What is the answer? 1.11. We don't, just remember the, don't do the calculation. Just remember the formula. What is the formula? RMS value by average value. Next one. Last one. Peak factor. What is the factor answer? Maximum value by, what is the maximum value? IM. What is RMS value? 0.707. IM will cancel. We get 1.41. So this is for current. This is for current. The same style. Ninth topic. Find the average value, RMS value, form factor, peak factor for alternating voltage. Alternating. Now write down the formulas. మీరే రాయండి. నైన్త్ చెప్పండి ఫార్ములా. వి యావరేజ్ ఏం చెప్పండి? 2Vm by pi. 2Im by pi. I average 2Im by pi. It is the voltage. 2Vm by pi is equal to 0.637 Vm. 0.637 Vm is the alternating voltage. Ninth topic. This is the eighth topic. This is the eighth topic. Ninth topic. Next one. V average is equal to 2Vm by pi is equal to 0.637 Vm. Now VRMS. IRMS. Vm by root 2. VRMS. Vm by root is equal to 0.770 Vm. Form factor same 1.11. Peak factor 1.41. It is alternating voltage. Ninth topic. Ninth. We'll check the ninth topic. This is the ninth topic. Find the average value, RMS value, form factor, peak factor for alternating voltage. What is x-axis? Theta or omega. What is y-axis? Voltage, because alternating voltage. What is standard equation? Apply the formulas. Apply the formulas. The answer will be 2Vm by pi. If it is a VRMS, the answer will be same 1.11, 1.41. So this is ninth topic. This is ninth topic. These are the formulas. These are the formulas related to AC circuit. AC circuit. Now pure resistance, 10th topic formulas. Right. This, you get a theory part also. Theory part. Explain about AC containing pure resistance only. 5 marks question, theory part. Or 7 marks question, final exam. Now we'll get 7 results. How many results? 7 results, 7 formulas. 7 results. We'll get. If we apply to the bulb is a load. Bulb is having a resistance R. Bulb is having a resistance R. Bulb is having a resistance R. This is called a bulb. Apply the voltage. What kind of voltage it is? AC voltage. Instead of telling the values 230, 440, 200, we don't have 230, 200, 100 volts. Instead of values, take the equation. Instead of values, we can apply 100 volts. We can apply 230 volts. We can apply 440 volts, depending upon the problem. Depending upon the, no problem is not there. Apply the equation. Apply the V is equal to Vm sin theta or sin omega t. We are applying the equation to the bulb. This is the waveform we are applying. Theta, y-axis, current voltage. Called equation. V is equal to Vm sin omega to the bulb. Bulb will glow. Bulb will glow. And if you go and switch on the bulb, bulb will glow or not? Switch on the board, bulb will glow or not? So we are switch on means we are applying 230 volts. We are applying, that is RMS values. If I say voltage is 230 means it indicates that it is RMS value. Always I won't mention RMS value. Simply mention voltage in AC. Voltage in, it indicates that it is RMS. Whenever you switch on the board, automatic voltage will go to the bulb, bulb will glow. Bulb will, and this is called is glowing. While bulb is glowing, what is happening inside the bulb under running condition? What is happening inside the bulb? Bulb is glowing. When we apply the voltage to the bulb, bulb is glowing. What is happening inside the bulb? Then we'll get 7 results. How many results? The 7 results we have to discuss. This is under operation. I'm applying voltage to the bulb. I applied a voltage to the bulb. Current will flow through the bulb. Then we'll get 7 results. How many results? 7 results we have to discuss. Only formulas we'll discuss. The first result is current. This is the final result. If you apply V, we got the answer. I is equal to Im sin theta. This is the result 1. Totally how many results? 7. What is the first result? I is equal to Im. We got the result. I is equal to Im sin theta. Whenever we apply a voltage to the bulb, current I is equal to Im sin omega t or theta. Or theta. So this we got it. Next result, second result. Phase angle. Now phase angle. What is the phase angle answer? 0. Why it is 0? See the equation. Here V is equal to Vm sin theta. Output is I is equal to. Now compare these two equations. This is plus 0. Omega t plus 0. It is also plus 0. See the difference. 0 minus 0. Phase angle is 0. Phase angle is 0. Comparing equations of voltage and current. Comparing equations of voltage and current. We got a phase angle. We got a. What is the phase angle? 0. I will ask you the question. What is the phase angle for pure resistance? 0. I will ask you the question. What is the current through the resistor in AC circuit? What is the answer? What is the current for pure resistor? I is equal to Im sin omega t. I is equal to Im sin omega t. This is the answer you have to give. This second one. First result, second result. Next one. After getting 0, you have to make a sentence. Which is the output? Current is the output. Which is the input? Voltage. So current is in phase. Is in phase indicates that it is 0 degrees. You have to make a sentence now. What is the sentence? What is the sentence? Current is in phase with voltage by 0 degrees. How can you say is in phase? Comparing equation of current and voltage. Current and voltage. What is the current equation? I is equal to Im sin omega t. What is voltage equation? V is equal to Vm sin omega t. Comparing the both equations, I got is it is a confirm that phase angle is 0. Phase angle is 0. Once we get to 0, we can make the sentence now. What is the sentence now? Current is in phase. Is in phase indicates that it is 0. It is a confirm one. This is called second result. What is the second result? Confirm 0 degrees. Now make a sentence. What is the sentence? Current is in phase with voltage by 0 degrees. This is second result. Totally how many results? 7 results. Out of 7 results, how many completed now? 2. What are the 2? Current and angle. And angle. Now we'll go for the third result. What is the third result? It is a waveform. It is a waveform. Now go for the waveform. Now check the waveform. Now this is voltage. This is voltage. Now this is current. The dotted indicated is current. Now check the current starts at 0, voltage starts at 0. See this one. 0 minus 0, 0. Now these are same. It reaches 90, voltage also reaches 90. First voltage reaches 90, immediately current reaches 90. 90 minus 90, 0. Now voltage reaches 180 degrees, current also reaches 180 degrees. What is the answer? 0. Now voltage reaches 360 degrees, current also reaches to 360 degrees. What is the answer? It is satisfied? Yes, this is called waveform. First voltage will go, immediately current will start, same angle it will start. If voltage is 0, current is also 0. If voltage is 90 degrees, current also 90 degrees. If voltage is 180, current also 180. Voltage 360, current also 360. Wherever it see, you get 0. You'll get. So this is the waveform. X-axis current and voltage 0, pi, 2 pi. This dotted line is called a current and this is called a voltage. Voltage current. We have to draw this waveform. This is called third result. This is called third result. This is called third result. Clear all of you? This is called third. How many results completed till now? 3 results completed. Now fourth result. Now we have to draw the phasor diagram. Now we have to draw the phasor diagram. Now it is very difficult to analyze with waveform. Now it is very difficult to analyze with waveform. I cannot analyze with waveform. All the waveforms should come into my mind while analyzing the circuits. I cannot draw the waveform in my mind. So I want to remove that waveform. The new technique I want to use. The new technique I want to use. What is the new technique here? Phasor diagram is a new technique. Phasor diagram is a new technique. Instead of this one, both are equal. Both are equal. We can draw this one. Otherwise, we can draw phasor diagram. We can draw the phasor diagram. We can draw the phasor diagram. So what is phasor? What is? Phasor is a magnitude. It should have a magnitude. Rotate in anti-clockwise direction. Rotate in. That is called a phasor. It is drawn on x and y axis. It is drawn on x and y axis. Right. For example, if you take a current is equal to 10 at 30 degrees. Draw the phasor diagram. Draw the phasor diagram. Current is equal to 10 at 30 degrees. 10 is called magnitude. 10 is called 30 is called angle. 30 is called what is the phasor? It should have a magnitude. It should have a magnitude. Rotate in anti-clockwise direction. Rotate in. If you rotate in anti-clockwise direction, or take plus values, plus 10 degrees, plus 20 degrees, plus 30 degrees. If we rotate in clockwise direction, minus 10, minus 20, minus 30. You remember this one. What is the phasor? It should have a magnitude. Rotate in. If it is rotating angle, what is the angles? Plus 10, plus 20, plus 30. If it is rotating clockwise direction, minus 10. You have to remember this one. Then you can draw the phasor diagram. Otherwise, you cannot draw the phasor diagram. Otherwise, you cannot draw the phasor diagram. We have to remember the sentence. Now draw the diagram for the current. I is equal to 10 at 30 degrees. I is equal to 10 at 30 degrees. Now see the diagram. It is drawn on x and y axis. Confirm. It is drawn on x and y axis. X and y axis. Now current is rotating from x-axis. Now current is rotating from, it is drawn on, it is drawn on x and y-axis. Phasor diagram is drawn on x and y-axis. So x-axis, this is called x-axis. Now rotate the current. Should I rotate in clockwise or anti-clockwise? Anti-clockwise. Why it is rotating anti-clockwise? Plus 30. Plus 30 means anti-clockwise. Minus 30 means clockwise. So plus 10 degrees, plus 20 degrees, plus, this is called plus 30 degrees. 30 degrees. This is called current. What is a magnitude? 10. This is the diagram. This is the series one. From x-axis, I'm rotating the current. From x-axis, I'm rotating the series one, like this. 30 degrees. What is the current magnitude? 10. It is rotating. Next example. I is equal to 5 at minus 10 degrees. Draw the phasor diagram. I is equal to 5 at minus 10 degrees. Draw the phasor diagram. It is drawn on x and y axis. X and y axis. X and y axis. From x axis, we should rotate the current. From x axis, we should rotate the. Now, shall I rotate clockwise or anti-clockwise? Clockwise, confirm. Why it is clockwise? Minus. Minus means clockwise, like this. How many degrees? From x-axis. So, this is called minus. This is called current. This is called current. What is the magnitude? 5. What is the angle? 10. Just enough 10. Because clockwise is minus. Clockwise means, see the magnitude. Here magnitude is 10. See the magnitude. 10. See the magnitude. See the magnitude. 10. See the magnitude. 5. It is very large, year to year. Now see this one. Small, very small. Very small. So this is called phasor. This is the concept of phasor. This is called. Now we'll go for the fourth topic. Now we will go for the fourth topic, fourth result. Fourth result. Right? Now draw the phasor diagram for pure resistance. Draw the phasor diagram for pure resistance. What is the angle? 0. Pure resistance, what is the angle? 0. Right. It is drawn on x and y axis. Phasor is drawn on. First, I will take voltage is the reference one. A bit current is the reference one. A bit voltage is the reference one. B bit current is the reference. We have two quantities. How many quantities we have? Voltage and current. Voltage is the reference one. Second, I will take current is the reference one. First, voltage is the reference one. Second, current is the reference one. Then I will take. Draw the voltage. What is meant by voltage is the reference one? Indicates that voltage taken as the reference one indicates that we should not rotate voltage from x-axis. It is constant. That is the indication. Voltage is reference. What does it indicate? It should not rotate from x-axis. It should be constant on x-axis. V does not rotate. V does not rotate. That is called reference. That is called reference. But who should rotate? Current should rotate. Who should rotate? Two quantities, voltage and current. Voltage is reference one. It should not rotate. It should lie on x-axis. It should lie on X-axis. Then who should rotate? Current. From where? X-axis. From where? X. Right. But current also does not rotate. But current also does not rotate. It is also lies on X-axis. Why it is lies on X-axis? 0 degrees. Current has to rotate from X-axis. Current has to rotate from, but current is not rotating. Why? 0 degrees. So can I satisfy the, see this one? The voltage, current. Both are in phase. But diagrams, we won't explain y-axis. We won't draw like this. Only will mention x-axis. Only mentions, but actually it is drawn on x and y-axis. Actually it is drawn on, but in textbooks we won't mention x and y-axis. Just we will draw the line. Just we will draw the line, just like this. This is the actual diagram. This is the diagram. Now go for current is the difference one. Current is the, what it indicates? Current is the difference, indicates that it does not rotate. It lies on x-axis. It lies on, we should not rotate. It is constant, fixed. It is fixed on x-axis. But then who should rotate? From where? X-axis. What is the angle? 0. So this is called 0. V is in phase with current. V is in phase with current. Now check the sentences. Now voltage is the reference one, second place. Current is the first place. This is called first place, this is called second place. Reference is the second place. Reference is the second place voltage. Current is the first place. Current is in phase with voltage. Now current is the second place. Why it is in second place? Reference one. Reference one. Who's rotating now? Voltage. Voltage is in phase with current. Both are equal. Both are. Now tell me which is the easiest one? Waveform is the easiest one or this one is the easiest one? This one is easiest one or this one is the easiest one? Phasor is very easiest one. Very easy to analyze the circuits. To analyze the circuits. This is called phasors. This is called fourth topic phasor. Fourth topic phasor. Fifth topic. How many topics totally? 7. Now impedance. V is equal to IZ. For what is the formula? Ohm's law in AC circuits. In V is equal to IR. Ohm's law in DC circuits. V is equal to IR. Ohm's law in DC circuits. V is equal to IZ. Ohm's law in AC circuits. AC circuits. Now, but what is that we have to find out? This is our target. This is called load. It depends upon the load. Z will change, depends upon the load. Z will change, depends upon the load. What kind of load it is? R load, L load, or capacitive load. Z will change. V is equal to IZ. Ohm's law in AC circuit. Now we have to find out Z. Now we have to find out Z. Z is equal to V by I. Z is equal to V is equal to Vm. Convert into maximum values. Convert into maximum Vm by I. Im, where we got from result 1. Im is equal to Vm by R. From where we got it? Result 1. How many results? 7 results. How many results? We got Vm by R. From where we got this one? Result 1. Result 1. We have this one. This formula we have. Im is equal to Vm by R. If you get this one, Z is equal to R. Remember that Z is equal to R. For pure resistance, what is Z? Answer. For pure resistance, what is Z? Answer. R. You have to tell R. Z is equal to R. Z is equal to R. This is fifth result. This is fifth result. Now sixth result. Now sixth result. Power factor. Now sixth result, power factor. It is defined as the cosine angle of between voltage and current phi is equal to 0. Cos phi is known as power factor. Cos phi is known as power factor. What is the angle here? 0. Cos 0. 1. You have to tell that what is the power factor for pure resistance? 1. What is the power factor of pure resistance? 1. This is the answer. But what is power factor? Cos phi. What is power factor? Cos phi is called a power factor. Last result. The last result, remember this formula. P is equal to VI cos phi. The last result, P is equal to VI watts. These are called 7 results formulas. Pure resistance, 7 results. Pure resistance, 7 results. 10th topic, pure resistance. Theory part, you have to write down all these 7 results for 10 marks question. For 10 marks for 10th topic. 10th topic. How many topics totally? 15 topics. Unit 2. Unit 1 AC circuits. Totally 15 topics. But our target to do the problems. Our target to do the problems. If I want to go for the problems, I need the formulas. Without formulas, I cannot do the problems. That's why I need some theory. Next one. 11th topic, inductance. Only formulas we'll discuss. First result, formula 1. Write down the formula. This is the formula. I is equal to Im sin omega t minus 7 results. 11th topic, pure inductance. 11th topic, pure inductance. How many results? 7 results. How many results? What is the first result? Current. What is the equation? I is equal to Im sin omega t minus pi by 2. Minus pi by 2. Minus pi by 2. Minus pi by 2. Now compare these two equations. What is the current equation? I is equal to Im sin omega t minus. Check these two equations. V is equal to Vm sin omega t. I is equal to Im sin omega t minus pi by 2. Here plus 0. Here minus pi 2. What is the difference? Plus 0 minus pi by 2. What is the difference? 90. What is the difference? How you got 90? Compare two equations. Compare two equations. What is the first equation? V is equal to Vm sin omega t. V is equal to, what is the current equation? I is equal to Im sin omega t minus pi by 2. Compare these two equations. It is confirmed that angle is 90 degrees. Angle is 90 degrees. Plus 0 minus pi by 2. Plus 0 minus pi by 2. Angle is 90 degrees. Confirm it is 90 degrees. Phase angle or phase difference. What is angle? But we have minus 90. Minus indicates that it lags. Minus indicates that lags. The current lags voltage. Current lags voltage by 90 degrees. This is input, this is output. Current lags voltage. Why we got lags? Why we got lag? Because minus 90 degrees. I is equal to Im sin omega t minus pi by 2. Minus, we got minus. That's why it's clear that lags. Current lags. What is the output? Current. What is the input? V is equal to Vm sin omega t. What is the output? Current. I is equal to Im sin omega t minus pi by 2. That is the output. That's why current lags. Current lags the voltage by 90 degrees. Current lags the voltage by. This is called result 2. This is called result 2. Result 3. How many results? 7 results. First voltage will start. First voltage will start. Don't try this one. After exactly 90 degrees, current will start. Check this one. First voltage will start. Exactly after 90 degrees, current will start. First voltage will start. After 90 degrees, current will flow. That's why current lags. That's why it is called current lags. Clear all of you? From here we have to start. Voltage. Current. This is current equation. What is current equation? I is equal to Im sin omega t minus pi by 2. What is voltage equation? V is equal to Vm. First voltage will start after 90 degrees gap. After 90 degrees gap, current will start. This called waveform. This called third result. Now fourth result, phasor diagram. Phasor. What is A bit? Voltage is difference. What is B bit? Current is difference. What is A bit? What is B bit? So you now you have to remember the sentence. What is the sentence? Current lags voltage by. Where we got this sentence? Second result 2. Where we got this sentence? Current lags voltage by 90 degrees. Result 2. You have to remember in your mind while drawing phasor diagram. While drawing phasor diagram, you have to remember sentence. Current lags voltage. While drawing phasor diagrams. While drawing, current always should lag. Current always should in such a way that you have to draw the diagram. In such a way that you have to draw the diagram. Always current lags. Always, if you listen inductance, you have to tell it lags. Whenever you listen the inductance, what is the answer? Lags. Who lags? Current lags. That is called pure inductance. That is called pure inductance. What is meant by pure inductance? What is meant by pure inductance? 10th topic is the pure inductance. Means it indicates that we don't have a resistance for the coil. చాలా ఉంది థియరీ చెప్పాలంటే టైం వేస్ట్ అయిపోతుంది. We have so many topics. Right. It is drawn on x and theta or omega t. What is x-axis? Current or voltage. Current or voltage. Now, which is the reference one? Which is the reference one? Voltage. Voltage is the reference one. Voltage is the reference one. It is not a waveform, it is a phasor diagram. It is not a waveform, it is a phasor diagram. Voltage should not rotate from x-axis. Voltage should not rotate from. Then who should rotate? Current. So it is the lags. Current lags means shall I rotate clockwise or anti-clockwise? Current should lag. If I rotate like this, current leads. Plus 10 degrees, plus 20 degrees, plus 30 degrees. Current is moving forward. Current is moving. Current goes into lead. Current goes into. So current should rotate in anti-clockwise direction. Anti-clockwise direction. -10 degrees, -10 degrees, -20 degrees. Like this, current will rotate. So this is the diagram. Remember this diagram. Go for the next topic. Fifth topic. V is equal to IZ in AC circuits. V is equal to IZ in AC circuit. We have to find out the Z value. So Z is equal to V by X. Convert into maximum. Vm by Im. Im is equal to Vm by omega. Where we got this value? Result 1. Inductance result 1. Im is equal to Vm by omega L. How you got this value means result 1. Result 1. So this finally we got omega L. Omega L. Omega L is nothing but a 2. What is omega? 2 pi F. Can be written as XL. Can be written as inductive reactance. Inductive reactance. This is called fifth result. Sixth result. Power factor. What is power factor? Cos phi. What is power factor? Cos phi. What is phi angle? 90. Cos 90. 0. What is the power factor for pure inductance? 1. 0. What is the power factor of pure resistance? 1. Cos 0. 1. What is power factor? Cos phi. What is power factor? No value. I asked value. What is the value for power factor for pure resistance? 1. Cos 0, 1. Power factor value for pure inductance? 0. Next, last one, seventh result. The seventh result is answer P is equal to 0. The answer P is, we don't have a formula here. P is equal to 0 watts. P is equal to, for pure resistance, what is the formula? P is equal to VI. P is equal to, but power is equal to 0. Power is equal to, for example, this fan is an inductive load. Fan is a inductive load. When you switch on the fan, current is flowing, it is rotating. Are you paying bill for the fan if you use for 1 hour? Yes. Now my assumption is the fan does not have a resistance. The fan does not have a, if there is no resistance, no heat. No resistance, no heat. Impossible case. Even though it is rotating, my assumption is that R is equal to, there is no resistance. Then what is the power consumption? 0. Wherever there is a resistance, we get heat. Heat will do some work. It is an inductive load which is having a resistance. Practical case. It is called a practical case because it is made up of copper wire. It is made up of, confirm it is have a resistance. If there is a resistance, there is a heat. If there is a heat, it is rotating, doing some work. Doing some, pay bill for that work. Pay bill for that work. It is rotating. You are using, pay it. Pay the bill to the electricity department. Now my assumption is the inductive does not have a resistance. Does not have a, if there is no resistance, no heat. What is the power then? 0. Impossible case. We don't get this kind of 11th topic. We don't get 11th topic, impossible case. Practical case, we should have a resistance. My assumption that this inductive load does not have a resistance, pure inductance. Pure? Impossible case. What is the power answer? 0. Impossible case. We should get some formula. If I take for 10th topic, pure resistance, we got the formula. What is the formula? P is equal to VI. 7 results, pure resistance. 7 results, pure resistance. 7th result, P is equal to VI. If resistance is there, there is a power consumption. Confirm. Because we got the formula. P is equal to VI. 7th result, pure resistance. Pure. But here, what is the power? 0. Impossible case. We don't get this kind. But we have to analyze the circuits. Clear? 7 results is completed. Same thing, pure capacitance. Next topic, 7 results. Next topic, 7 results, pure capacitance. What is the power consumption? 0. Why it is 0? Assumption that capacitor does not have a resistance. Assumption that capacitor does not have a resistance. If there is no resistance, no heat, no power. No heat, impossible case. We don't get 7 results. We don't get, but we have to analyze the circuits. We'll discuss 7 results for pure capacitor. Then we'll go for the for direct problems. So pure inductance is going to be, if you get a question on pure inductance, write down these 7 results. Write down these 7 results. Pure inductance, 7 results. If we get for 10 marks question, we will get for 10 marks question. Now 12th topic. What is the 12th topic? AC circuit containing pure capacitance. Pure. What is when indicates pure capacitance? Assumption that we don't have resistance, no heat, no power. Impossible case. You take any kind of material, even human being having a resistance, bench is having a resistance, steel bar, everything we should have a resistance. That is confirmed. But my assumption that capacitor does not have a resistance, no heat, impossible case. But what is the power answer? 7th result? 0. 7th result, what is the 7th result? 0. Why it is 0? No resistance, no heat, impossible case. Impossible. 7th result is P is equal to 0. Pure inductance, what is power? 0. Pure resistance, what is power? P is equal to VI formula. 7th result. P is equal to VA. We got the formula. Check it. Seventh result, pure resistance. What is the formula? P is equal to VI watts. P is equal to, because we have a resistance, we get the formula. We should get the formula. Because we have a resistance, we get a heat, we get a power. We have a resistance, we get a heat, we get a power. P is equal to VI watts. P is equal to VI watts. Pure inductance, what is power? Zero. Pure capacitance, what is power? Why it is zero? No resistance. No resistance means no heat. No heat. Impossible case. The last one, 7 results. Note on the formulas fast. Right. First result, write down. I is equal to Im sin omega t plus pi by 2. What is the first result? I is equal to Im sin omega t plus pi by 2. I is equal to Im sin omega t plus pi by 2. I is equal to Im sin omega t plus pi by 2. Pure inductance, what is the current? What is current? Pure inductance. I is equal to Im sin omega t minus pi by 2. Result 1. What is current here? Plus pi by 2. I am talking about the current, not power. I am talking about the current, not power. Not power. Pure resistance, what is current? I is equal to Im sin omega t. I is equal to Im sin omega t. Pure inductance, what is current? I is equal to Im sin omega t minus pi by 2. Pure capacitance, what is current? I is equal to Im sin omega t plus pi by 2. Plus pi by 2 minus pi by 2 to 0. These are results, we got it. These all are called, comes under result 1. Result out of 7. Out of 7. Now compare the two equations. What is the angle now? 90 degrees. It is plus 90. Inductance minus 90. Capacitance plus 90. Inductance minus 90. So plus 90 means current leads. Plus 90 means current leads. Plus 90 current leads. Plus 90 current leads. Minus 90 lags. Whenever you listen the capacitance word, always current leads. Whenever you listen the word capacitance in AC circuits, always current lead. If it's a pure inductance, always current lags. If it's pure resistance, always is in phase. Is in phase. Next result. You go for this one. V is equal to Iz. Z is equal to V by I. Convert into maximum. What is Im? Omega C omega Vm. Where we got from this one? Result 1 of capacitance. Result 1 of, check my notes later. Check my notes later. Right. 1 by omega C. Remember this formula. Remember this one. Remember this box. Remember this box. 1 by omega C is equal to 1 by 2 pi fc is equal to xc ohms. 1 by omega C is equal to 1 by 2 pi fc is equal to xc ohms. Remember this formula. Remember this formula. Right. Power factor. Value of power factor 0. Pure inductance 0. Pure resistance 1. Pure resistance 1. Pure inductance 0. Pure capacitance, why it is 0? 90 degrees. Cos 90 0. No resistance. We can say no resistance also. We can say no resistance also. But I need the value 90 degrees. What is the power? Last power. What is the power? Why it is 0? No resistance, no heat, impossible case. Is it formulas? This all comes under 7 results. 7 plus 7 plus 7, 21 results. 21 results. Now we'll go for the problems. Right. సార్ ఇది రావట్లేదు ఇది పెన్ డ్రైవ్ పెట్టి చూసాను. Right. We have to do 3 points. One is pure resistance, one is pure inductance, one is pure capacitance for the pure inductance, pure capacitance, pure resistance. Three problems we will do. Okay. Right. Write on the question. It is on pure resistance. It is on pure resistance. Write on the question. Please write down the question. An AC circuit. This is one type of design, one problem. If you have all the formulas in your mind, then you can do the problems. Otherwise, it is very difficult to do the problems. Saying now itself. You should have all the formulas. Whatever we discussed till now, you have to remember the formulas. An AC circuit consists of pure resistance of 10 ohms. Of 10 ohms. And is connected across an AC supply of 230 volts, 50 hertz. Calculate current, phase angle, power consumed, power factor, equations for voltage and current. Draw the phasor diagram between voltage and current. Right. Given data. You have to do practice. Right. Given data. What is R is equal to 10 ohms. V is equal to 230 volts. It is VRMS. Remember that. 230 volts means you won't mention VRMS, just V. AC circuits. 230. What is the frequency? 50 hertz. Right. This is the given data. First one, A bit. Current. So which formula will use? Right. The formula, I will tell you. V is equal to IZ. In AC circuit, V is equal to IZ. Ohm's law. What is that for pure resistance? Can I say V is equal to IR? V is equal to IZ in Ohm's law. In AC circuit. Confirm. Right on. V is equal to IZ. Ohm's law in AC circuit. A bit current. A bit current. V is equal to IZ. Ohm's law in AC circuit. But what is that for pure resistance? That is good R. Pure resistance, what is that? R. Can I say V is equal to IR? Yes, we can say V is equal to IR. Yes, we can say it is V is equal to IR. We got it. Right. I is equal to V by R. I is equal to V by R. What is V? 230. What is R? 10. What is the current flowing through the circuit? 23 amperes. 23 amperes. Given data. R is equal to 10 ohms. V is equal to 230 volts. F is equal to 50 hertz. A bit current. V is equal to IZ. Ohm's law in AC circuit. V is equal to IZ. V is equal to IZ. Ohm's law in AC circuit. But what is that for pure resistance? Z is equal to R. Pure resistance Z is equal to R. Then what is the formula? V is equal to IR. V is equal to I is equal to V by R. What is the current flowing through the circuit? 23 amperes. 230 by 10. Right. B bit. Heading phase angle 5. 5. We have to find out 5. This is 5. Phase angle 5. Directly you can note down. What is the phase angle of pure resistance? 0. What is the phase angle of pure resistance? 0. Write down. The phase angle between voltage and current is 0. The phase angle between voltage and current. Voltage means VRMS. Current means IRMS. The phase angle between voltage and current is 0. Therefore, phi is equal to 0. Therefore, phi is equal to 0. Make a sentence here. Current is in phase with voltage. Make a sentence. Current is in phase with voltage. Make a box. B bit is completed. Phase angle heading. Phase angle heading. The phase angle between voltage and current is 0 degrees. Therefore, phi is equal to 0. Therefore, phi is equal to 0. Therefore, phi is equal to 0. Make a sentence now. Current is in phase with voltage by 0 degrees. Is in phase is enough. It indicates 0 degrees. Is in phase is enough. It indicates 0 degrees. B bit is completed. C bit. What is C bit? Power consumed. Seventh result. Power consumed. Seventh formula. P is equal to VI. P is equal to VI watts. Seventh result. Power consumed. The names for power consumed is average power, true power, power consumed, simply power. All this comes under same names. Names are different. Power consumed. What is the formula? VI. What is V? What is I? 23. What is the parts? 5290 watts. 5290 watts. Watts. Power consumed. Seventh result. C bit power consumed. Heading. Formula P is equal to VI. Watts. What is V? 230. What is I? 23. What is answer? 5290 watts. 5290 watts. Next one. Power factor D bit. Heading D bit. Power factor. What is the power factor of pure resistance? 1. Cos phi. What is phi? 0. What is phi angle? Cos 0. 1. Finish. Answer. Power factor heading. Write down cos phi is equal to cos phi is equal to cos 0. Cos phi is equal to cos 0 is equal to 1. Power factor heading. Cos phi is equal to cos 0 is equal to 1. Next, E bit. E bit. Equations for voltage and current. Equations for what is the voltage equation? V is equal to Vm sin omega t. Write down. E bit. Write down E bit. Equations for voltage and current. Heading. Heading. Equations for voltage and current. Heading. Clear? Right. Equations. Write down the equations. What is the equation of voltage? V is equal to Vm sin omega t. Equation of voltage is V is equal to Vm sin omega t. What is current equation? I is equal to Im sin omega t. I is equal to Im sin omega t. Now we have to find out right. This is called equation of voltage and current. Now we have to find out Vm value. Now we have to find out Vm value. Now we have to find out Vm value, Im value, omega. Three values we have to find out. After getting the values, substitute in the equation. Three values we have to find out. Vm, Im, omega. After getting the values, substitute in the equation. That is called equations of a voltage and current. That is called equation of voltage. Find out Vm. Any formula? Vrms is equal to? Can you find out Vm? Can you find out Vm? Right. Irms is equal to? Im by root 2. Can you find out Im? Right. Find out. Omega formula? 2 pi f. Find out. Find out Vm, Im, omega. Find out Vm, Im, omega. Vm, Im, omega. How to find out Vm? Formula. Vrms is equal to Vm by root 2. Find out Vm. Irms is equal to Im by root 2. Find out Im. Next, find out omega. Next, find out omega. Substitute in the equations. Substitute in the equations. These are the equations. 325.27, omega 314, omega 314, current. Current is equal to 30, Im, Vm. This is Vm, this is Im, this is omega. Find out the values. Vm, Im, omega. Vm, Im, omega. We have to find out. How to find out Vm? Formula. Vrms is equal to Vm by root 2. Get Vm. How to find out Im? Irms is equal to Im by root 2. Get Im. What is omega? 2 pi f. These are the formulas. These are the formulas. Get the answers. Can you get 10 marks? Final exam. Last one, phasor diagram. Now, which is the reference one? I is the reference one taken. I is the reference one. Draw the phasor diagram. Draw the phasor diagram. Pure resistance phasor diagram. Current is the reference one. We have taken current is the reference one. Current should not rotate from x-axis. It is fixed. It is fixed. So which one is we should rotate? Voltage. From where? X-axis. Shall I rotate or stay in the same place? Same place. Why? 0 degrees. So will you get 10 marks for final exam? Next problem 2. Inductance. Problem 2. Inductance. Pure inductance. Pure inductance. What is power? Pure inductance. What is power? 0. Why it is 0? No resistance. Assumption. No resistance means no heat. Impossible case. Pure inductive. Second problem. Problem 2. Problem 2. కాఫీ చెప్తారా సార్ సార్ కాఫీ చెప్తారా సార్ రైట్ ఆన్ ద క్వశ్చన్ ప్యూర్ ఇండక్టెన్స్ రైట్ గివెన్ డేటా about notes. Show me the notes. Have you written the problem? Given data. What is current flowing to the circuit? Pure inductance 10 amperes. What is voltage given to the pure inductance? 230. It is RMS value. Always, I will never mention RMS, just is about it. How many frequency applied? 50 Hertz. First one, inductive reactance, A bit. What is symbol? Inductive reactance. చెప్పే కదా. Z is equal to XL, fifth result. Z is equal to XL. XL is equal to 2 pi FL. 2 pi FL. 2 pi FL. Right. The first one is A bit. So what formula we have applied? First A bit. Inductive reactance. V is equal to IZ. A bit. V is equal to Ohm's law in AC circuit. But what is that? XL. What is that? XL. V is equal to IXL. V is equal to IXL. V is equal to IXL. XL is equal to V by I. We get XL. Again, once again. A bit. Inductive reactance XL. Inductive reactance XL. Formula. V is equal to IZ. Ohm's law in AC circuit. Ohm's law in. But what is that for pure inductance? Z is equal to XL. Z is equal to V is equal to IXL. V is equal to XL is equal to V by I. We got XL in ohms. In ohms. A bit is completed. A bit is completed. XL. Depending upon the situation, you have to select the formulas. You have to select the formulas according to the situation. Problem. What is answer? 23 ohms. XL is measured in ohms. XC is measured in ohms. R is measured in ohms. Z is measured in ohms. Right. Next, B bit. Now I want L. B bit into inductance L. I need L value. L is measured in Henry. Unit 1 DC circuits. Unit 1 DC circuits. Inductance is measured in Henry H. That we have to find out. That we have to find out. How can you find out L? XL is equal to 2 pi FL. You know XL. You know F. Can you find out L? Yes, you can find out L. Yes, you can find out L. Apply the formula. What is the formula? XL is equal to 2 pi FL. B bit inductance heading. B bit inductance heading. It is measured in Henry, capital L, not XL, capital L. XL is called inductive reactance. L is called inductance. Coil. What is the formula applied? XL is equal to 2 pi Fn. What is L then? 0.073 Henry. 0.03 Henry. Now C bit. Now C bit. What is the phase angle between voltage and current for pure inductance? 90 degrees. Theory part. This is called theory part. Pure inductance theory. 90 degrees. Which is the result? 90 degrees. Result? Second result in pure inductance. Second results in pure inductance. How many results? 7 results. How many results? Second result, 90 degrees. Second result, that is the answer. Theory part. The phase angle between voltage and current for pure inductance is 90 degrees. Next one, D bit. Power factor, cos phi is equal to cos 90 is equal to 0. Heading, power factor. Power factor means cos phi. Power factor means cos phi. What is phi? 90. Cos 90? 0. 0 is the answer. E bit. What is E bit? Power absorbed, power consumed, meaning same. Average power, meaning is same. Whatever it may be. Average power, true power. These are the names given to. What is the answer? Zero. 0 watts. Why it is 0 watts? No resistance. Assumption only. Impossible case. Coil ki resistance లేదు. Coil ki copper wire ki resistance లేదు. Impossible case. F. Equations for voltage and current. What is voltage equation? V is equal to Vm sin omega t. What is current equation? I is equal to Im sin omega t minus pi by 2. Minus pi by 2. Now we have to find out Vm, Im, omega. Substitute in the equation. Substitute in the equations. How to find out Vm? Vrms is equal to Vm by root 2. Get Vm. How to find out Im? Irms is equal to Im by root 2. Get Im. How to find out omega? 2 pi m. After getting the values, substitute in the equation. After getting the values, substitute in the equation. It is for 5 marks to 7 marks question. So that inductance problem completed. If you know the formulas, then only it is possible to calculate. Otherwise, it is very difficult to calculate. Yes. అయిపోయిందా మీది? Have you completed problem 2? Problem 2. Inductance. Problem 2. Inductance. Completed? Next, problem 3. Capacitance. How many results? Capacitance. 7 results. 7 results. Capacitance. What is the 7th result? Power consumption. Answer. Pure capacitance. 0. 7th result, power consumption, P is equal to 0. Assumption that no resistance, no heat. Impossible case. Practice, practice. So that you will get marks. So maximum problems. But you need to lot of practice, take different kind of textbooks and practice it. Right. Go for what is C value? Capacitance value, which is measured in farad. Which is measured in farad, units farad. Pico means 10 to the power of minus. V is equal to 230. First one. First, what is the first one? Capacitive reactance. Capacitive. It is measured in Xc. Designated as Xc. Capacitive reactance. Xc. Inductive reactance. XL. Capacitive reactance. Xc. Measured in ohms. Measured in ohms. Right. What is the formula? 1 by omega C. What is the formula? What is omega? 2 pi f. The form 1 by 2 pi fc. Xc is equal to 1 by omega c is equal to 1 by 2 pi fc is equal to 1 by 2 pi fc. Micro means 10 to the power of minus 6. 10 to the power of, if you go upside, 10 to the power of 6. Denominator is 10 to the power of minus 6. Now it is going to the numerator, 10 to the power of 6. 2 pi frequency 318 into 10 to the power of minus 6. If you go up numerator 10 to the power of 6, the answer is 10 ohms. The answer is 10 ohms. 318 into 10 to the power of minus 6. 318 into 10 to the power of minus 6. Going into denominator, 10 to the power of 6. A bit. A bit. A bit capacitive reactance Xc is equal to 1 by omega C is equal to 1 by 2 pi Fc is equal to 10 ohms. Is equal to 10 ohms. B bit. B bit. B bit. RMS value of current. IRMS simply called as I. Simply called as I. V is equal to IZ. Ohm's law in AC circuit. What is it? Xc. What is it? Xc. Therefore, V is equal to Ixc. V is equal to Iz. V is equal to Iz. But Z is equal to Xc. Therefore, V is equal to Ixc. Your mistake is there. I have done a mistake. Mistake. అదే రాసుకున్నారు. ఇది VC రావాలి. ఇది VC రావాలి. VL is equal to V. ఏం కాదు. VL is equal to V. I'm talking about the inductance. C ఇక్కడ VC. I'm talking about the capacitance. I'm talking about the VC or V. VC or V. VL or V. If it is a pure inductance. VL or V. Capacitance. VC is equal to V. We can write it. Not to worry. What is the current flowing through circuit? 23 amperes. Next one. What is the phase angle? 90 degrees. Pure capacitance, what is the angle? 90 as per theory. As per theory, 90 degrees. Debit. Power factor cos phi is equal to cos 90 is equal to 0. As per theory. Phase angle is between voltage and current is 90 degrees. Phi is equal to 90. Power factor cos phi, cos 90, 0. Power consumed, 0. Why it is 0? No resistance, no heat. Impossible case. power consumed, power absorbed, true power, average power, the meaning are same meaning because of resistors. Hello, Bob. Bring notes. Have you written? Show me the notes. Have you written this one? Why? What is the reason? Okay, you can meet and come to Dean, sir. You meet Dean, sir. You will call to your parents. Sit. Right. What is the equations? V is equal to Vm sin omega t. I is equal to Im sin omega t plus pi by 2. Plus pi by 2. Find out Vm. Find out Im. Find out omega. Okay, we can check all these notes so that we have completed AC circuits. We have completed the AC circuits. So these are the different kind of questions we'll get in the previous question from previous question. Clear? Right. Measurements unit 2. Unit 2, we have two topics, machines and measurements. Machines and machines, the questions are DC generator, we have discussed four questions. DC generator, four questions we have discussed. DC motor, one question. Explain the working principle of DC motor. Explain the working principle of transformer, four questions. Induction motor and alternator. This comes under machines. This comes under machines. This is one part, part A. Unit 2, this is another part. This is another part, measurements. We have 5 questions on measurements, 10 marks questions or 5 marks questions. The 5 questions are classification of electrical measurements, 10 marks question. Classification of electrical measurements, 10 marks question. Second question, essential of indicating instruments. Second question. Torques, damping torque, controlling torque, and deflecting torque. One more question. Next question, PMMC question, 10 marks question. Moving iron, 10 marks question. Wheatstone bridge, 10 marks question. Totally 6 questions from measurements as per JNTU syllabus previous question papers. You have to read all those questions, then only you get 10 marks. Otherwise, you won't get 10 marks. All totally measurements, 6 questions. I have divided into 6 questions. First question. Classification of electrical measurement instruments. Define absolute instrument, define secondary instrument. Or explain classification of electrical measuring instruments. 5 marks or 10 marks. 5 marks are 10 marks. Classifications. We have two types of instruments. One is called absolute instrument. The other is called secondary instrument. The other is called secondary instrument. Two types of instruments. Absolute instrument. Absolute instrument. Secondary instruments. Two types of instruments. Classification of electrical measuring instruments. How many types? Hello? How many types? Classification of two types. What are they? Absolute instruments, secondary instruments. Absolute. What is meant by absolute? Example, galvanometer. Example, galvanometer. Example, galvanometer is those instruments which give the value of the quantity to be measured in terms of constant of the instrument and its deflects are called absolute instrument. What does it mean? So example, galvanometer. Okay. Example, galvanometer. Now secondary instrument comes under, I will explain only examples. These, these instruments in which electrical quantity became measured given direct. Whenever we will measure, automatically show the deflection. Whenever we want to measure, it will show the deflection. Once we get the deflection, we will measure it. Immediate secondary instruments. All called secondary instrument. The example are power station, substation, industries all used comes under secondary instruments. Comes under secondary instrument. These are all definitions. Not to worry. It is the theory part. Elaborative we can explain, but is no time. We have only already 3:30 completed. Within half an hour, I have to complete all the questions. Now 3:40. Time is 3:40. Within half an hour, I have to complete all the questions. That's why I don't want to expand it. I don't want to expand it. Just definition is enough for me. Next question. Indicating instrument, integrating instrument, recording instrument. Okay, you have to write down all those things. I will send you the notes also. Okay, same. Write down these notes enough. Only this enough notes. Types of second instrument, indicating instrument, integrating instrument, and recording. All you write down this one. This first question. First question. Define recording instrument. 2 marks question. Write down this definition. Example. Write down this definition. Example. Now, important question for 10 marks question. 10 marks question. Essential of indicating instruments. You have to explain deflecting torque, controlling torque, and damping torque. 10 marks question. 10 marks question. You have to explain all those things. This called deflecting torque. This controlling torque. Controlling the two types. Spring control, gravity control. Spring control, gravity control. Spring control, gravity control. Two types we have. Explain two types. Control torque, how many types? Two types. Spring control, gravity control. Damping torque. Next is damping torque. Again, damping torque, air friction, fluid friction, eddy current damping. Eddy current. So all this, if you write, you will get 10 marks. All you should write. Essential of indicating instruments. Essential of how many torques? Three torques. What are they? Deflecting torque, controlling torque, damping torque. Damping torque. Again, controlling torque is divided into two types. What are they? Spring control, gravity control. Spring control, gravity control. Damping torque. Last one is damping torque. Damping torque is divided into three types. Air friction, fluid friction, and eddy current damping. So if you write all those things, then single question 10 marks. You can write my notes enough. 4 to 5 points. Next one, PMMC. Construction, diagram, operation. Enough. If you want, you can go for deflected torque also. If you want, then advantages, disadvantages, applications. 10 marks question. 10 marks. Construction, working principle. Diagram comes under working principle. Diagrams come under working. Next one, that deflecting torque derivation. He may ask, he may not ask. Okay, if you want, you can take this one. Okay. Next one, advantages, disadvantages, application for 10 marks question. 10 marks question. Next one, moving iron. Moving iron. Construction. We have two types of moving iron. Attraction type of moving iron, repulsion type of moving iron. Repulsion type of moving iron. I think you may get only one, right? Any one of moving iron instrument. He may not ask two. Okay. Anyway, if depending upon the marks, depending upon the marks. So first one is attraction type. First one is construction, diagram, working operation, repulsion type. Construction, diagram, working operation, advantages, disadvantages, applications for 10 marks question. Moving iron. Moving iron. Next, last one, Wheatstone Bridge. Last one, Wheatstone Bridge. Don't go for other notes. My notes is enough. Don't go for your wish. That is your wish. I will send you the PDF. Sixth one, last one, Wheatstone Bridge. Wheat construction, working operation with diagram, then derivation. It indicates derivation. What is the final answer? P by Q is equal to R by S. Applications, limitations. Enough. This is called for 10 marks. Construction, working principle, derivation, application, limitation. 1 mark, you may get the 1 mark bit. What is the limitation of Wheatstone Bridge? 1 mark bit. You can write down. What are the advantages of Wheatstone Bridge? 1 mark bit. You can write down. So these are the 6 topics comes under measurements. Comes under measurements. So machine, measurement, AC, DC, all are completed. All are. Only one topic is left over. What is the topic? Third unit. What is it? Energy sources, electricity bill, safety measurements. We have not discussed. Anyway, we'll discuss that one also. Only checking notes, notes checking. You'll get some confidence on you. Okay, unit 3. Unit, only notes checking. What to read? Right. Energy sources. Five questions. Energy sources, 5 questions. Hydropower plant definition, layout, and working operation. Nuclear power plant, wind power plant, solar power plant. And these are the 5 questions from energy sources as per your syllabus. You got this. You can check the previous question paper. Direct question. Explain the layout hydropower plant. 10 marks. Single question. Single question. Explain the layout hydropower plant. Single question, 10 marks. So what we have to write? So this is the definition. First one, definition. You got this question. Site selection and factors affecting the location of dam of hydroelectric power. You got this question. For 5 marks, I don't know the exact marks, but you got the question. How to select the site before going to the planet? Install the plant. What is site selection? So we have to write down the site selection. This is called site selection. Availability of water we should have. We should have availability. Lot of water we should have before going for the hydropower plant. Before going for the site selection. We call it as site selection. Availability of water. Second one. Storage of water. Storage of water. How to store the water? How to store the? We have to construct the dam. We have to construct the to store the water. It's very important. First is availability of water. First is, next is storage of water is very important before installing the hydropower plant. Next one, third one, cost and type of land. We have to check the land and cost. What is the cost of the land? Next, fourth one, last one, transportation facilities. It is very easy to go and come and go to the plant whenever required. Whenever So these are the four important before selecting the site. Check the site. Availability of water, storage of water, and cost and type of land, and transportation facilities. You got this question, site selection question. So you can read my notes. Clear? Next one. Construction layout. Construction layout of hydro plant. Construction and layout for hydro. All single question, 10 marks. Single question, 10 marks. So what are the construction? We should have water reservoir, dam, trash track, spillways, control gate, penstock. All this should be have in your layout design. While designing, you have to select all the components. First, select the components, then make the design. Select the components, then make the design. So, description about water reservoir. See, I have given total notes. You can write only, you can take the important points. I have given the notes. You can take, read all the things, whatever you get in your mind to write it up. Read all the sentences. Whichever you remember, you write it. You'll get the marks. Next one, dam. Next one, trash track. Next one, spillway. Next one, control gate. Next one, penstock. Next one, value nozzle, turbine. This is the diagram. Okay, you can draw this diagram. Otherwise, if you draw this diagram, any one diagram, your wish. I have given two diagrams. This is the reservoir. This is called a reservoir dam. This is called control gate to control the water. This is called a penstock. This is called a penstock. This is a control gate. This is called a penstock. It is higher potential. This is lower potential. It is called a turbine, which is connected to the conductor. Yesterday I told you. Turbine is connected to the armature. Conductor. I told you. It is connected to the conductor. Turbine should be connected to the armature so that armature will rotate in the magnetic field. Armature will rotate in the EMF is induced in the armature. EMF is induced in the armature. So this is the turbine. You can check. You can write on any one diagram. This diagram or this diagram, your wish. Generator, powerhouse, transformer, total 15. Then working principle. Advantages, disadvantages. This is one question. Site selection, construction, working principle, advantages, disadvantages. 5 things. Whichever they will give the answer, you write down. If they ask advantage, disadvantage, write down. If they ask only construction, write down. If they ask only site connection, write down. He may ask anything, we cannot tell. But he will ask only this only. Final. This is called hydropower plant. This is called hydropower plant. Next one, nuclear plant. Nuclear plant, 10 marks question. Nuclear plant definition, basic principle, site selection. Again, site selection is very important. Where we have to select the site for to install nuclear power plant. Nuclear power plant. So availability of water, disposal of what waste material. So all these 8 points. 8 points. This is the layout diagram. This is the layout diagram. You cannot don't go for this one. To understand purpose, I have written. You can go for only this diagram. You can go for only this diagram. Same, both are same. To understand, I have gone for this one. This is a practical case. You can draw any, don't draw this diagram, draw the upper one. Draw the upper one. Next one, these are the components required. Nuclear reactor, heat exchanger, steam turbine, condenser, cooling towers, water treatment. Explain each component. Explain each component. Then working operation, how it works. Then advantages, disadvantages. Advantages, disadvantages. Same thing for solar plant, same thing for wind energy. Same style. Site selection, construction, working principle, advantages, disadvantages. All are same. Clear? All of a 10 marks question. So that we have completed. We have completed energy sources. We have completed energy source. Still we have two topics. What are the two topics? Electricity bill. Next one, safety measurements. Safety measurements. That's good notes. We will give you. We have the notes. My notes is enough, I think so.
I'm just closing the session.
Okay.
Yes. చాలా 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 బాగుంది ఇది.
Thank you.
అమ్మా, we are very grateful to Kamalaker గారు. సార్ వాయిస్ మీన్స్ అండ్ ఒకటి ఏంటంటే ఎక్సలెంట్ సార్. నేను ఆర్కే సార్ కూడా చెప్పాను. సెకండ్ థింగ్ ఏంటంటే ఈ వేళతో క్లాసెస్ అన్ని క్లోజ్. ఓకే, మేము చేయాల్సి ప్రతిదీ ఈసారి 1% ఏ బ్యాచ్ కి జరగలేదు అలాగా. ఓకే సార్ అన్ని కూడా ఇందాక విన్న ఫ్యాజర్ డయాగ్రామ్స్ కానీ ఇంకోటి కానీ అన్ని చెప్తున్నారు. సో అయిపోయింది ఇంకా. ఇప్పుడు మీ షెడ్యూల్స్ చెప్తున్నాను చూసుకోండి. ఇంచుమించు 157 మెంబర్స్ కోవిడ్ వాళ్ళే వచ్చారు లోపలికి, గర్ల్స్ బాయ్స్ కలిపి. అండ్ ఉమెన్స్ లో కూడా చాలా మంది వచ్చేసారు. సో వీఆర్ అప్రిషియేట్ దిస్. ఈసారి ప్రోటోకాల్స్ కింద తయారైపోయింది. డేస్ కాల్స్ కూడా చేసుకుంటున్నాం లోపల. ఎందుకంటే మాకు తెలుసు ఏం జరుగుతుందో బయట. మొబైల్ వచ్చింది. ఓకే, అండ్ అది పక్కన పెడితే ఫస్ట్ ఆఫ్ ఆల్ జెడ్బిఎల్ ఇస్ టార్గెట్ 1 మంత్. క్రిస్మస్ ఏదో ఫెస్టివల్ మాత్రమే. యాక్చువల్ ఫెస్టివల్ ఎప్పుడు సెలబ్రేట్ అవుతుందంటే వెలుగుతూ వచ్చింది. అక్కడైనా రైట్ ఒక్కొక్కరు దీపావళి దీపావళి అప్పటికి పడుతాడు. ఇప్పుడు నెక్స్ట్ 10th డీజే కూడా ఏం లేవు. 10th ఈవినింగ్ డీజే గ్రాండ్ మ్యూజిక్ ఇస్తారు. 11th కూడా సంక్రాంతి చేసి పంపిస్తారు ఇక్కడ. సో అంతవరకు డెడికేటెడ్ గర్ల్స్ అందరూ కూడా అక్కడ రామకృష్ణ లేరు ఎలాగైనా ఏం లేదు. 1000 కళ్ళతో మొత్తం మార్నింగ్ ఫిక్స్ అని వచ్చేస్తాయి అక్కడ. మధ్యలో బాయ్స్ దగ్గర ఎక్కువ ఉంటున్నారు అట్లయినా. అండ్ ఏంటంటే మొత్తం అన్ని సబ్జెక్టు డెడికేటెడ్ గా ప్రెజెంటేషన్స్ అన్ని చెప్పేస్తాను ఎలా రాయగలరు. ఎందుకంటే బంధం అంటూ వాళ్ళకి ఆనందం గట్టిగా రాదు. బాయ్స్ మళ్ళీ చెప్తున్నాను 28 పేజెస్ రాయాల్సిందే కంటెంట్ లో. అది ఇంటర్ కాదు, ఇంటర్ పాస్ చేస్తున్నారు, తోసేస్తున్నారు 400-500 వేసేసి 1000 అది గవర్నమెంట్ పాస్. అవన్నీ ఇంజనీరింగ్ వచ్చాక కంటెంట్ తోనే కొట్టాలి. రేపన్నీ 28 పేజెస్ మినిమం ఉండాలి కంటెంట్ తో. అందుకోసం ఎంత శ్రమ పడాల్సి వచ్చింది. సో చదువు అంటే ఇప్పుడే స్టార్ట్ అయింది. అసలు ఆల్ క్యాబినెట్ సైన్స్ చదువు ఆల్రెడీ గొడవ చేస్తారు. పేరెంట్స్ కూడా వచ్చేస్తారు. అర్థమైందా? అప్రిషియేట్ చేస్తారు. నేనే మళ్ళీ చదువు అంతవరకు చాలా పేషెన్స్